My name is Aultman-Hall. I am a professor of systems design engineering here at the University of Waterloo. So I've always focused on transportation systems, and originally I started studying traffic engineering, so congestion, and my undergrad research was on the QEW here in Ontario. And then as I moved into my PhD studies, I started working on bicycle transportation, and I did some quantifying of actual risk rates on paths versus roads versus sidewalks for bicycle crashes and falls. But over about the last decade, I sort of accidentally fell into two areas. One which is related to long distance travel, so it involves when are you traveling on the ground in a vehicle and when are you flying in the air, to be able to look at travel patterns and when and where people are flying versus traveling on the ground. And a very important question we need to ask ourselves for the national aviation system is which trips are best left in the air and which trips are best moved to electric ground transportation. And the other is electric vehicles, and where and when do we want to charge those electric vehicles in order to minimize the carbon emissions from the combined transportation electricity sector. You know, really almost everything we do in our society is a system, and we want to deal with not only the technological or the physical aspects of a system that traditionally engineers have been associated with, but also think about the social elements of that system, maybe the economic elements of that system, and as well as the all-important environmental impacts, which can include not just thinking about polluting the water or the air, but also the type of environment we live in, quality of life and wellness. So you can think about a robot as a system that's got physical parts, but when we think of societal and environmental systems, we think of systems that might have physical parts as well as non-physical parts. So something like the transportation system is actually an excellent example, because that includes humans, right? It includes these things that can't be programmed very well. They don't behave as well as concrete. Humans make decisions, they have behavior, and if we're going to sort of design an optimal transportation system, we've got to account for those human elements as well, and we want to account for the environmental impacts and the quality of life and the wellness and everything that flows from that system, not just the things that are easy to design like the motor of a vehicle.